Hello and welcome back to STEAM with Steve. Today we're going to keep pushing through the Pythagoras concepts we've covered so far and move on to the shorter side in the right angle triangle we've been looking at. So let's dive on in. So this lesson is going to cover the shorter side that we'll find within the Pythagoras rule that we've looked at. So to start, just a bit of a warm-up exercise. When you look at your TV or your computer monitor, it's actually measured in inches. And instead of from side to side, it's actually from top corner to bottom corner. So it's either this way or this way, right? Now, when you hear a 55-inch TV, that's what it says that the measurement is. Now, what we're going to do is actually explore these measurements and see if they actually align with what they really are. So a 32-inch TV, for example, usually has a base of 75 centimeters and then a height of 45, and then a 90, 50, 93, and 52, and then a 97, 56 all the way up to 43 inch. Now we're going to use a bit of Pythag here and see what we can do with a 32 inch TV and see how accurate that is. So a lesson intention that we're going to cover, we're going to go through that TV example. We're going to revise Pythagoras' theorem first, and then we're going to derive another version. So if we want to find the shorter side, that's what the version will be. And that will allow us to find the shorter side in a right angle triangle using Pythagoras. So just pause the video there. See if you can have a crack at this question. So if the 32-inch TV has the measurements of 45 by 75, prove that it has a 32-inch TV has a 32-inch diagonal measurement. And then we note that 1 inch is equal to 2.54 centimeters. So let's have a little go here. So to start, that's basically what we've got. We've got two triangles. We've put that diagonal in between. And you can use either the top or the bottom. It doesn't really matter because both these sides here on the left and the right are 45. And then the top and the bottom are both 75. So I'm going to choose to use the bottom one here. So 45 and then the 75 there with little right angle. So first rule, we can see that we've got a Pythag question. So we're trying to find the hypotenuse here. So h squared is equal to a squared plus b squared. We fill in the blanks. So 75 squared plus 45 squared. That gives us 5,625 plus 2,025. So then the area of h squared is 7,650. So imagine a little square popped off the top there. That's how many units would be there in centimeters squared. So then to find the hypotenuse, we would do h is equal to the square root of 7,650, which then approximately equals 87.46 centimeters. Now this doesn't tell us whether or not it's 32 inches yet. So the last step then is we need to divide it by 2.54. And lastly, we can see that it is equal 34.43 inches. So this means that your TV ads are lying to you. If you don't, it's basically a stock standard of that 32 inch, but you can see that you've actually gotten a little bit more. Now, my recommendation is to go out and measure those TV panels because sometimes you might be able to get a 35-inch TV when it's only a 32-inch TV. Kind of cool. Awesome. So this was another really interesting video that I found that shows the Pythagorean theorem. Now, the way that it works is it basically puts 4 of these triangles around the edges here. And what you'll find if you stack this green triangle with this green triangle, you'll see that it equals b squared. B times A. And then this side here will equal A times B over here. But then the empty void space, if you push this down here, is the same as B times B. And then the empty void down here will be A times A, which hopefully you'll pick up when you'll see the animation. So this area, this void space in black here is equal to C squared, because if we look here, we've got C times C. And it's one of the classic ways of showing the way that this works.
Start with a right triangle with legs of length A and B and hypotenuse of length C. Now, draw an A plus B by A plus B square. We can fit 4 rotated copies of the triangle in the square like this. Notice that the space in the square not covered by the triangles is a square of side length C. Therefore, this unshaded area is C squared. We can also move the same colored triangles together to form 2 different A by B rectangles.
So the top left is A squared, and you got B squared.
It's given by an A by A square and a B by B square, so that the unshaded area is A squared plus B squared.
Which then proves it.
Consequently, we have seen that C squared must be equal to A squared plus B squared, This is the Pythagorean theorem.
Pretty cool. So we're going to have a crack at the worksheet. There's a quick, the top 3 questions, which will be in the next video. So if you're not quite sure, have a look at that. So the next step then is we want to work out the case of the missing side. So if we're given the hypotenuse and we don't know that side, and we do know this side, what rule could we do to find that mystery side of the shorter side? Now my hint to you is usually when you use Pythag, you'll add the 2 sides together. This time around, you'll need to subtract. Now it's really important if you've got the bigger area, you have to subtract the smaller area from that hypotenuse squared. Otherwise, it just won't make sense. So what is this value? If we had 5, we don't know that. We know that side's 3. We should remember the original Pythagorean triplet that we've covered a couple of times. So that side there would be 4. So the way that you could work that out is you would do the 5 squared minus the 3 squared, right? Which would give you 16. And then you square root it and you get your 4. So that's one quick way. The more concise way of doing that, though, is to write a formula. So if we've got the hypotenuse, we've got B and we've got A, and we want to rearrange it so we've got make A the subject in this case. We've got H squared is equal to A squared plus B squared. What we can do is we can subtract the B squared from both sides. So we're going to subtract that B squared from both sides. Now this effectively cancels this side out. That's gone. If I have B squared, then I take away B squared, it's gone. That leaves us with A squared, which we're going to put over this side, and then we just write on the other side. So then A squared is equal to H squared minus B squared. And that's the second rule of Pythagoras that you'll need to remember for the upcoming exam. So to rearrange B as the subject, which you don't necessarily really need to do because you just make sure it's always the shortest slide, we can do that as well though. So if we've got this triangle here with the A, B, and the H squared is equal to, we take away A squared from both sides with the hypotenuse. That cancels out in the middle, and you're left with B squared is equal to H squared minus A squared. So the 2 rules that you need to know is these. Just choose one. I usually just remember that A squared is equal to H squared minus B squared. And then I just make sure I plug in the right sides so that sort of works. So the first example to show you how this works, if you're given the hypotenuse of 13 and then 5, we first would write the rule. So I always write A squared is equal to H squared minus B squared. And then I fill in the gaps. So the hypotenuse in this case is 13 squared minus the 5 squared. We then solve it. So 13 squared then gives you 13 times 13, which is 169. We then take away 25 and we get that equal to 144. So then the area, see how it's smaller than the 13 squared. So then we do A is equal to the square root of 144, which then leaves us with a 12. And that's what that missing length is. So just to graphically show you what's happening, you've got 169 there, you've got 25 there. If you subtract them from each other, those areas, that equals that remaining area, which is 144. Pretty cool. And then you do the square root of 144, and that leaves you with the 12. First challenge. So pause the video, have a go, see if you can work out the area, the missing length here. So you've got a 10 and a 6. What is that missing side? Awesome. So what you should find, we write the rule first. So A squared equals H squared minus B squared. Fill in the gaps. So we've got 10 squared minus 6 squared. 100 minus 36, we get 64. And then we do the square root of 64 to find just the side, and we get 8, which hopefully you've picked up as a Pythagorean triplet again. So we go 10 squared equals 100, 6 squared equals 36, and then this missing area is equal to 64 because we've subtracted from each other. Notice that the side is smaller, which is good. So a good check is if you've got a missing length here and this is bigger than the hypotenuse, then you know that your calculation has gone severely wrong. Cool. So the last one then, we've got example number 2. We're going to go 11 and 7. I'm going to follow exactly the same process. We're going to go A squared equals H squared minus B squared. 11 squared minus 7 squared. So 11 times 11 is 121 minus the 49, which leaves us with 72. We then want to find just the side. So we square root the A a squared, which gives us 72, square root 72. And then that approximately equals 8.49. So just to graphically show you what's happening, that square blue area is 121, the area down the bottom is 49. We subtract them from each other and we're left with 72. To find the side, we must square root it, which then gives us the 8.49. So that's hopefully worked there. Challenge number 2, pause the video, have a go with that. Awesome, so what you should have found, again, a squared equals h squared minus b squared, because you're trying to find that shorter side. We then fill in the blanks, so we got 13 squared minus 9 squared, so 169 minus 81, which then leaves us with 88. You then do the square root of 88, which leaves you with 9.38, which should be approximate there as well. Cool, so 13 squared gave you 169, 9 squared gave you 81, and then this side here left you with 88, and then you square rooted it and got 9.38. There's a second Pythagorean sheet there that you should be playing with. If not, we've got some more time next lesson. So you should be able to find the shorter side in the triangle, derive Pythagoras' theorem, a squared equals h squared minus b squared equals h squared minus a squared. They're pretty straightforward. So there's the homework there, chapter 3M, pages 182, questions 3, 4, 5, and 6, and then the challenge questions for 10 and 11 if you want to push yourselves. That's it for me. Hopefully you've picked up a few things with Pythagorean's theorem there to find the shorter side. The more you practice with this, the easier it becomes. So hopefully you've got the two different formulas. You understand h squared equals a squared plus b squared only works for the bigger side. And then a squared equals h squared minus b squared is for the shorter side. Thank you very much. Hope you've enjoyed. See you next time on Steam with Steve. Adios.